Ideas. Good morning, everybody. Thank you very much for the kind introduction, and I'd also like to thank Henry and Scott and the whole LSI team for having me today. Thank you. You've actually helped me by inviting me to the event. You've actually forced me over the last couple of months to push hard on my thesis of TechMed. What I'd like to do today is explain a little bit about how I came to this thinking about the industry. I'll share a little bit of my own personal journey to it, talk about what I think it is, what it means, and share a couple of examples of how it's occurring, and hopefully leave some time at the end so we can make this a little bit more interactive. And I'll also talk a little bit about deep tech. One of the things that was very striking to me about this week is when I think about what's going on in AI, I had the pleasure of working and funding a company by a man named Yoshua Bengio. Yoshua Bengio and Yves LeCun were graduate students. They did their PhD under Jeffrey Hinton, who was recently of Google. They are effectively the parents of neural networking and AI. And if you think how neural networks work, you inform multiple nodes. And if I think about the LSI event, you meet somebody, they introduce you to somebody else, they bring in knowledge from a third party. That's how neural networks work. They collect information from the outer peripheries and they feed that back, and that's actually what machine learning and neural networking does. So that's a little bit, I think, what I've been able to get out of this event just in the last couple of days. I've learned a lot about how the industry works. I'm not a traditional medtech investor or medtech entrepreneur. I've met some amazing people, and I've seen some really great companies, and several of them super interesting to me and the firm. So how did I get here? And then we'll talk about how TechMed got here. I come from the tech industry. I've spent a couple of decades, almost 3 decades, in tech. I started my tech career working for 2 little companies, one called IBM and the other Cisco. At IBM, I built 2 e-commerce businesses in the mid-1990s. People may remember June 5th, 1995 was my first day at IBM. It was also the launch of Windows 95, and it was also roughly the time frame of the IPO of the Netscape browser. I worked there several years. I launched several businesses. I'm not an engineer. I actually had to start this from scratch and make that journey. A couple of years later, I moved to Cisco during this internet wave, and Cisco at the time, and probably still for a good part of even today, was the underlying infrastructure for the internet. Over 95% of the traffic on the internet ran on switches and routers that were built by Cisco systems. The 2 lessons I took away from IBM and Cisco in building businesses there is that it's much easier to build a business if you're satisfying demand versus creating demand. And if you looked at the internet enablement of organizations, of individuals, the growth of e-commerce, the growing of Amazon, and the ease of it was to both access information as well as to transact on the internet, drove an enormous wave of investment and consumer and business behavior. And that was kind of my orientation for getting started. In the early 2000s, I got very excited about the startup world. So I was where many of the companies here are today. My first startup, Tahoe Networks, which is conveniently not on my slides, was a gigantic fireball. It was a terrible miss. It was the only company backed by Jim Getz, who's at Excel, who's now at Sequoia, and Jeff Yang at Redpoint that actually didn't make money. I managed to work for that one. Tahoe built infrastructure to allow mobile devices to connect to the internet. The problem is that there were no 3G devices. There was no iPhone. There was no tablets. There was no Android. So we were all dressed up with no place to go. And the company ultimately exited as kind of an acqui-hire for Nokia because it had very good technology. And so I kind of learned my lesson. And then I worked for 3 very pivotal companies in the technology industry as a chief product officer and COO. First one was a company called Airspace. Airspace was the first company at scale to allow people to set up wireless LAN systems. In fact, we won the largest customers in the world, but we didn't do anything that somebody who wasn't paying attention to. At that time, Intel put a chip on every laptop called Centrino, and pretty much everyone wanted to take their laptop and connect through Wi-Fi to the internet. So we did a great job at satisfying demand. The company was acquired by Cisco, and I had a brief stint back with my old employers. It was much better to be acquired than take a job there. It was definitely a way to go. I then worked for a company called Nicira. Nicira virtualized networking. We turned it from hardware into software. It was acquired by VMware by $1.3 billion. We had $400,000 in revenue. We were acquired because we were actually the pivot to pressure the entire change in the industry and the growth of the cloud from a networking point of view. So it became a very strategic linchpin. And then my last company was a company called Illumia, which is a cybersecurity unicorn. It's a company currently worth $3 billion. And it turned network security into software. So I think you'll see 2 themes here that I think is very important as we think about the TechMed thesis, which is that hardware and software are fusing and changing in very transformative ways. And number 2, the drive from the end customer is always going to be the most important element. Then something happened in my career. In 2016, my father was diagnosed with glioblastoma. He had surgery at Mount Sinai Hospital in New York. And during his cogent year, he basically talked me out of working in tech. He asked me, what are you doing? You've done this a couple of times. Do you really need to do this going forward? And I thought about it, and I called him up one day, and I said, thank you. On the bridge to mortality, you just put a bullet in my career. And he really made me start to think about where I can put the remaining professional years that I would have more productively to doing something that would actually have more long-lasting impact on society. One thing I learned about my father as he was dying is that he was a Navy corpsman during the Korean War. He was called up as a reserve. He was too young for World War II, but he was in the reserves, and he was parachuted from an aircraft carrier, not literally parachuted, but moved to Korea, where he was on the wrong side of the Chosin Reservoir when a very large Chinese army came across. He actually conducted field surgeries as a corpsman. I still have his SCLAR surgical kit from 1950, wrapped up in the canvas and all of the sutures and all the things that he had, and it got me thinking about the practice of medicine. I was recruited to DCVC. They were investors in my company, Evolve, and I joined them. And initially, I worked with 3 companies. Evolve Technology is a company we built and took public in the weapons detection space. It uses an array of sensors and computer vision to know whether you have a gun or an iPhone in your pocket. If you went to the Olympics this year, you walked through Evolve. If you walk through 1/3 of major league sports in the United States, you will walk through Evolve. If you go to the cricket stadium in the Australian cricket stadium in Melbourne, 100,000 people having a good time, you'll walk through that. I also worked with Caption Health, which might be a little bit more familiar. Caption Health satisfied a problem that we have a huge gap in the number of sonographers and doctors that can complete EKGs using ultrasound. So we built a software platform using algorithms to actually provide guidance for a non-trained medical staff, and could be a Navy corpsman, it could be a medical assistant, not a nurse practitioner, not a doctor, not a cardiology, to actually follow the guidance and actually capture the EKG, including the ejection fraction, accurately. That was a company that 2 years ago was acquired by GE Medical, who saw the competition with Butterfly and the movement from large cart-based systems to portable point-of-care ultrasound handheld devices, and said we have to have it. And at the end of the day, that's what happened. And I spent time also, I mentioned, with Element AI, which was the open AI of Canada, led by Yoshua Bengio's team. When I make investments, I look for one critical factor, and it's part of our deep tech thesis, is are we providing a level of human enablement? Are we giving superpowers and skills to people to do their job better, to be more effective, to provide more information and data to that? And I've done this in robotics. I've done this in cloth manufacturing, in wireless power, and I think an alumni of the LSI, many of you have heard of Proprio. I was the lead investor in their Series A, which I believe are creating superpowers for surgeons, and I'll talk more about that. So yeah, I kind of feel like if I can make my way to TechMed, my background, it's a layup for you all, because you actually understand this industry a lot better than I do. So let me take a minute and just define deep tech to you, our perspective, and I think the other takeaway I got this week, it would be useful to explain how we invest and how we think about companies. And I brought something for you. I've had somebody shipping it. So if you see on the table in the back, this is the DCVC Deep Tech Report. It highlights several of our companies. It also highlights our TechMed thesis, but it'll give you a sense on what an investor in my space is looking for, and it's very simple. We look for passionate entrepreneurs that are bringing a computational advantage to some scientific or tech sector and providing an enormous amount of leverage to what we think about as trillion-dollar problems. That's literally what we do. We swing for the fences. We fund rocket companies, robots, microbes that replace chemical fertilizer, and also passionate healthcare oriented entrepreneurs that want to see a huge transition in this industry, and for many reasons, including democratizing the ability of lots of people to take advantage of this care, as opposed to folks that have good insurance and are fortunate enough to live somewhere where there are great doctors that they can get access to. So that's our focus. Let me talk about TechMed. It's really not very complicated. Our TechMed thesis, and you can see this in the articles and you can see this in our report, is a speciation event. And in biology, a speciation event is when a new species emerges out of an existing species. So TechMed is emerging out of med tech. It's not something completely different, but it starts with a different focus. It's when an array of new technologies, not all of them are brand new, which include an array of sensors, computer vision, machine learning, and most importantly, proprietary data sets, large individual, regional, population, and cross anatomical data sets come together to be able to provide the medical establishment skills and capabilities to perform highly relevant clinical interactions and provide better outcomes from patients. Not really very complicated. But the thing that's different is that we start from the technology basis, and I'll share some examples of that, and then think about how they get applied to medicine, as opposed to somebody who is in an area, they're in cardiology, they're in orthopedics, they're in an array of disciplines in medicine who go looking for technology to solve the issue. We come at it, and sometimes it's quite accidental. So that is what effectively TechMed is. When you look at AI technologies like ChatGPT, you're seeing what we think about as the superpower game of AI, where people are spending billions and billions of dollars to train large models, right? And these models take in audio, images, written words, text, knowledge, and they string it together, right? That's effectively back to the neural network. It's a very, very different game. In fact, if anything, Larry Ellison was quoted last week. By the way, if anybody saw the Larry Ellison, it's worth seeing. And I want to look like Larry Ellison when I'm 80. He looks terrific. I don't know what he's doing. I don't think it's plastic surgery. I think he really has great doctors, and he's taking care of himself. He thinks to train the models that are going to win, the 1 or 2 winners, is going to take $100 billion. I know there's a lot of companies here that are looking for funding. That's a different game. That's a very different game. But with that, you can use something like ChatGPT or Midjourney or Gemini or a range of tools, and you can ask it to create an image. It will do that. You could say, I would like to see Gandalf the Wizard from the Lord of the Rings fly fishing. And, in fact, I might do a quiz. One of the images that are in my presentation was actually generated with ChatGPT. I used it myself for the presentation. When I look at the opportunity, and I'll talk about this in somatic AI, it's actually opposite. What the medical industry can do is take imaging, data, the brain power of practitioners, their knowledge, and actually create models in the opposite direction. So you can take images and create knowledge as opposed to take knowledge and create images. It's almost the inversion of what we're seeing in the ChatGPT movement. Now, if you're thinking about AI in your business, and we are an AI-first investors, the DC and DCVC stands for Data Collective. We are big nerds. My partner, Zach Bodek, 15 years ago started the Big Data Drinking Club in San Francisco at Founders Den. We invested in lots of the infrastructure for big data, including Elastic, Confluent, Databricks, companies that are really the on-ramps to do that. There's an enormous amount of money going into AI. But most of it, as you can see from this Goldman Sachs report, actually is going to the traditional industries that tech serves. So you see the information industry, financial services, education, things that you would expect. The growth of AI in healthcare, which, by the way, is a larger industry than many of the industries that are inhaling AI faster, is actually moving at a slower rate. That, I think, is part of the challenge, and I think it's the opportunity for the folks here at LSI and the people building in this industry is to smartly apply AI into what they're doing. And we should be seeing more of that money not just going into building models to write marketing copy, but into figuring out how to diagnose a pathology slide through computer vision, to work with patients to build things like digital therapeutics and ways to keep them on them. So this, to me, I think is the fundamental challenge in front of the industry, which is AI adoption is slow in an industry which, frankly, is dramatically more important to the lifestyle and quality of life for most people. Asking ChatGPT a question or asking it, what do you think my tax return should be, is fun, and you can do it. But using it as a practitioner or as a patient or somebody in administration to provide better health outcomes, to me, feels like a much more important use of this technology. So this is something I think we as professionals have to really keep an eye on this, because I think this should not be a lagging indicator. It's going to start from a smaller base, but it should have a faster trajectory. So here's an area, and if you're looking for a business plan to share with me and other tech investors in Silicon Valley, is something that I call somatic AI. So the term somatic obviously relates of the body, and I stole some images from my company, Proprio. So what you're looking at, many of you here know, is a view of the spine. One of the things that a lot of the companies that are building visualization systems can do is they can give you an enhanced view. This is a 3D view. It can also be brought down to the millimeter to examine for imperfection, to look for growths, and all of those things. And it can also measure when something is in alignment or if it is off. So somatic AI is what I think is going to be a branch of technology that is going to dramatically enhance the ability for us to understand the human anatomy, the interaction of anatomy with drugs, procedures, and medical devices. Now, for somatic AI to become successful, we need to fulfill the data promise of all of this, which means I saw a lot of really interesting companies with implants. Are those implants actually providing data about what is going on? When you're looking at one of the challenges with a lot of imaging is it's a point in time. Right? We all know if you have a checkup and you go to your doctor and your doctor takes your blood pressure, it's terrific, except he or she took it once a year and it's actually fairly irrelevant. So the goal of somatic AI is to master information, data about the human body, about people's health, about their interaction with all of the factors that they live their life, what you eat, how you move your body, how you sleep, and actually what your doctor and other professionals provide to you on how to administer your health. Somatic AI is a way to see that all, to visualize it, right? And this is a very visual industry, right? It's either one or two things in the medical industry. It's either very physical, you can see what's happening, or it is microscopic, and it is about cells and molecules. So I'm talking about the physical side of this. So this is an area that I think is going to really keep growing and take off. One of the ways to do that is to build better ways to continuously monitor information and build those data, that data river. I stole this slide from our company, MIC, which is a company that's built a monitoring system called SickBay. Its initial focus, it was built by machine learning scientists, is to take all of the measurements of a patient in a hospital, anything from infusion pumps to glucose monitors, all these things, and continuously monitor it. They did that by aggregating this. They could actually make clinical staff a lot more effective. Right? I mean, we know we have a nursing shortage, and if you are, so the ability to map an entire hospital's population and know when something's happening. But the real Trojan horse about SickBay is that it is measuring, and it is creating an enormous data set and aggregating it. And by the way, if there is a case of sepsis or an infection and it shows up in one patient, you would want to monitor the entire patient population. How does that start to get measured? So for me, the next turn of the crank for this will be for the folks in the medical device industry to have their implants, their devices, talking to something like SickBay. Right? We are quantifying ourselves as a society. So lots of really interesting opportunities, and then ultimately to create foundation models and digital twins. The ability to create population-level, regional, sectional, and individual data sets and make them alive for that. That is, I have a really close friend. We met 40 years ago at a running club, and she's one of the lead epidemiologists at CDC, and I called her last week saying, hey, I'm going to do this, and we said, Alan, I've been looking at data for 40 years. I'm glad you finally figured it out. So I think we know this, but we now have the ability to make sense of this data, to find patterns in a way that we haven't, and that, to me, is an extremely powerful opportunity. Not all of these capabilities have to be for the most specialized. I'm not the youngest person in the room, but I did not live when there were doctors made house calls. So if you ask a couple of generations in front of you, and probably until about the 1950s, and particularly in smaller towns, but sometimes in cities, doctors would actually come to your house. And what did a doctor have in their bag? They had a blood pressure cuff. They obviously had a stethoscope. They had a tongue depressor. They probably, had a thermometer, and then they had, they had Advil, and they may have had syringes with, with some stuff to bring to you. And the doctor came to you. And what was very wonderful about that era of medicine is you had a doctor, and they knew a lot about you. And if you didn't move around, they were with you for a large part of your life. I had a doctor for 20 years. He retired. It was heart-wrenching. He was an old-school doctor in my small town in California, and not only did he know me, he was the general contractor of everything in my health. When I messed up my meniscus, he was on the phone referring me to the orthopedic surgeon, right? He managed all of that. So on some level, he was the data lake, the data store for me, because I didn't know anything about that. I think we're going to start to see this collection of data, and I did see some folks that are, whether it's from wearables, whether it is from opening up the systems of these data to actually give the point of care practitioner an enormous ability to make decisions and work with you on your health based on comprehensive data. What's the worst thing that can happen to you in your healthcare? You move cross-country, and none of your records or frankly, the tribal knowledge moves with you. An enormous opportunity to improve health and health outcomes. I want to share two companies with you from an investment point of view. And I wanted to share, I think some may know a bit about Proprio. Proprio is a company that, interestingly, it is a medical device company. They built a navigation and an alignment system for surgery, but that's not why I invested in them. And I'll give you a clue on how you can hook a tech investor. When I went to visit Proprio in the fall of 2019, by the way, I made the investment during COVID and wired the money without visiting the company again. It was an interesting time as an investor, and we all know it was an interesting time for the industry. I saw something there that really struck me. I saw the most interesting and balanced team that I've ever invested in. There were real machine learning scientists. One of the founders of the Litro camera and key architects of it was there. There were medical device professionals. There was a prominent PhD level neurosurgeon, Sam Browd, as the co-founder. There was an energetic tech entrepreneur, Gabe Jones. What I saw were the fusions of disciplines that I thought could build a new platform in this industry. And what's most interesting to me about Proprio, it was not founded to be a medical device company. It was spun out of the sensor lab at the University of Washington. Jim Younghurst, one of the co-founders of the company, was a young PhD student working on light field technology. And for those who are not familiar, light field is a RGB. It is a video camera technology that is super intense in the amount of data it takes in. And it does two things. It measures the intensity of light, and it measures the directionality, which would be pretty useful if you were a surgeon. And it allows you to create this 3D image. But what we've discovered over the last couple of years, and what we're really working on, is they're effectively building a digital twin for surgery initially in spine. Right, they just had an announcement where they've, in the first half of last year, we finished over 50 surgeries. We collect 500 gigabits of data per surgery, which is all indexed, searchable, referable. So they are building a foundation model and a proprietary data set. Ultimately, I think that we'll have to find out. I'm an investor. I'm an optimist, right? I have to be. But that's actually what we're betting in. And that's why DCVC invested in them. We invested in it because of the data opportunity. If you told me in 5 years from now they're actually not making equipment, but they're actually providing those models and data to other people, I'll be okay with it. So data-first mentality is really important. But no one in the sensor lab and Jim Younghurst were thinking about surgery when they put their time into this effort. So that's a key finding for that. Second one, this company is in stealth, but I'll share with you. We invested in a company called Remedy Robotics. This is an autonomous catheterization robot. It does the high left definition. You guys are smart. You can figure that out. David Bell, who is a cardiac surgeon who worked in a cath lab, took inspiration from this fairly outrageous entrepreneur called Elon Musk and became fascinated with autonomous vehicular driving. Now, I'm not a cardiac surgeon. Actually, my wife is a cardiac nurse practitioner. She worked in a cath lab. I don't know if you want your cardiac surgeon to think about, running in full self-driving mode. but that's effectively what this is going to do. So, and it does two things. One, it focuses on how to remove or reduce some of the challenges that go on catheterization, right? It is not always a smooth procedure, and also the ability to deliver it autonomously over distance. It's important in stroke, but what it is doing, it is taking expertise and it is pushing it out to the periphery of the neural network, right? In this case, it's a catheterization neural network. So super interesting. This clearly was a medical professional, but changed his entire life because of what he saw in autonomous driving. It's really, really inspiring, and these are just two quick examples of how we think about that. So if you're going to build a tech med company, there's a couple of things that are worth really understanding. We believe that tech med companies start, and by the way, many of your companies I believe already have these elements, they start from a proprietary data set. You know more about a certain medical challenge than anyone else. You have collected the data and you've put it to work. That data, in that model, whether you're using transformers to build it or you're just pulling it, can actually impact human technique, how a medical professional does their job while they are doing it. Obviously, it's easy to visualize that in surgery, but if I go back to my doctor's visit, you know, he pulls out my chart, which I haven't seen him or her in a year. They ask me some questions. They touch you. They take your pulse. They do things. They make a decision, and then they prescribe care or they give you advice. What would change if more of this information was available to somebody who's really smart about making those decisions with you? So we see that happening. That post-procedure or post-interaction is augmented in real time by that. And what does it do? What comes out of the other side of that, it enhances the data set in the model on the other side. That's the virtuous circle. This is how you put data to work in tech med. I think it is fundamentally the most interesting technology opportunity for this entire industry. But it means you actually have to change your perspective on where data is and how it's used. And then ultimately, like everything else in medicine, there's really 4 goals of doing this. 1, to make the delivery of care more actionable, more precise, and more accurate. So obviously in surgery, that's a pretty easy one to spell out. Number 2 is to push down the cost curve. If we know one thing from Moore's law in the technology industry, is that every great technology pushes it down cost rapidly as it gets adopted. And that has another aspect of the virtuous cycle. It makes it available to more people. And ultimately, you can have 1 or 2 models. You can have something that's very expensive that few people can afford and will buy. Or you can have something that's very compelling and you can make it affordable and let more people derive that. Because I believe that 90% of the opportunity in front of this industry are people that are pretty much unaddressed today. And we have a giant growing middle class around the world that will expect the same great care that the people we all work with are delivering today, but they want it to happen in parts of the world where they don't have it. So they're not going to do that on the CMS reimbursement program. It's going to have to change. You increase that availability, and then healthcare becomes nitrated. It fuses through the human body and through our experience. A couple of things that I'll wrap up. I coined this term, and I call it a data river. If you think about a lot of, in data science, people talk about data lakes, and they talk about, which are basically large pools of unstructured data. And they talk about data houses, which are structured data. The power of the computing technology to actually draw inference from unstructured data is changing that game. And then obviously, machine learning is a huge contributor to that. But the fallacy of both of those, particularly in healthcare, is that it is a static element.
We are continuously, and I saw some great technology around glucose monitoring. There was a great company from San Diego I met with the other day. We have the ability to infuse our view of our health by constantly pulling data from aspects of that and correlating across that. I call that a data river. How do rivers start? A lot of them start with mountains. They're little streams, capillaries. They feed, and eventually you get something like the Mississippi or the Amazon or the Rhone River and other really important rivers around the world. So this is the change in how to think about data. Not a static set, but something that continuously moves all through your life. And for me, this is really simple. If you're going to build a tech med company, build with the data-first mentality. There is a lot of sanity to meeting the customers where they are, meaning and a lot of logic on not changing how they do procedures. But I think over time, we're going to redesign how procedures, how operating rooms, how we deliver care based on what that data does and how it is utilized. And I think that's coming. It's not coming tomorrow, but over the next 5 or 10 years, I think we will start to think about that. I see a lot of robotics, in particular in things like people's eyes. When robots are doing the work, how you do the prep room, how they go through the procedure, how they post, they're going to change. You're going to have leverage in different points and kind of intelligence in centralized. You have to engage the regulators. I think the most successful companies are going to be spending a lot of time educating the regulators about the change that is going on in their industry and working with them. I'm happy that we have an FDA. I don't want to be a guinea pig. But they are running as hard as they can to keep up with the AI movement and healthcare. And then finally, something that's a little bit different, you're going to have to build with cybersecurity in mind. We are infusing computing systems and data into the medical industry. Well, we've seen in the rest of our society, if you don't take cybersecurity seriously, so that's a bit of like the downer point here, but you actually have to think about that when you're building out what you do. So I think that we're already in this movement. I'm going to steal from William Gibson, and people know Necromancer and his books. The TechMed movement is already here. It's just not equally distributed. Thank you. I'll be happy to take any questions. It's Friday morning, and I stunned you into silence on the third day. Yes, sir.
The way that you and your portfolio companies are thinking about that flywheel of data capture, enhancement that powers the entire thing, maybe a little advanced for how some of the larger medical device companies, the strategics in this space, think about embedding AI into their existing businesses, adding AI features to legacy hardware products to sell more of that hardware product. The question kind of two parts. One, those large medical device companies are likely still one of the primary paths to liquidity and scale for these companies that you're investing in. How do you think about engagement with them and how they'll respond to this type of novel thesis? Where are they now and where do they need to be? And kind of the second follow-up to that is, do you think that with a new movement or speciation event in medtech like this, we'll start to see more pathways for these companies to achieve scale outside of the traditional acquisition by the large company, that we could see more new, larger tech med companies kind of come into the field of what we think of as strategics?
Thank you, Henry, for the most loaded question humanly possible. Well, I think there are some people, the panel before me, I see Elizabeth here, actually I think could provide a lot of insight on how strategics think about things. I think we're closer to the computing industry in tech med than we are to the med tech industry. And when the PC came out, interestingly, it was pioneered by IBM, but they built it across country from their main headquarters. The people who built mainframes and mini computers didn't really react. Ultimately, the big winners in that cycle were not the computing companies, they were really Intel and Microsoft.
and they created kind of the forces there. My company, Cisco Systems, which is the leader in network, pharma company, did it through rapid acquisition and a very agile mindset. I don't think a lot of people, particularly publicly traded companies, are going to change their business model overnight because of an insurgent with a different strategy. I think it's going to take a couple of the tech med companies going public, becoming compelling players, right, effectively alphas in the ecosystem before we see fundamental change, because it's really hard to explain to your shareholders why you want to slow down an existing product line and change it as you go. We would not have even the large language models, we would not have this entire change in generative AI if it wasn't for OpenAI pushing Google, Microsoft, and Amazon to begin the change. So I'm not sanguine that the large companies, they will do things. They're very smart and they're very well-run companies. I have huge respect for them. That isn't the issue. I mean, we saw, there were a lot of surgery companies 25 years ago when Intuitive started, and people were like, well, let's see how that robot goes, right? And I think the tech med industry is going to need an Intuitive robotics. Hopefully I'm investing in it. I'm about to find out in the next couple of years. But I think that is going to have to change. Or they're going to have to do what IBM did, which is they're going to have to empower an executive to create a division away from headquarters that will work as a skunk works to get there. But I think, collaboration with startups, I mean, it's not that it's not going to happen, but, nobody likes change. Nobody makes change unless they have to. If somebody says to you, you should exercise more, you should sleep better, you should do that, and yeah, you're right. And then if your surgeon says you're going to have a heart attack or you've had one, all of a sudden, come on, bring the GLP-1. I'm ready to go. I'm in the gym all day. So people react to change differently. I'm not giving you exactly the answer. I think this industry, the business model has to change as well as the technology has to change. And if you're selling razors and razor blades, and somebody wants to go after your blade business, that's a really tough business to make that transition. Maybe you can make the blades smarter. Remember, razor blades had one blade, then two, and now there's 5. But it's, people haven't fundamentally changed how that is. So I think the industry structure has to change as well. Time for one more question.
Well, that was exactly where I was going to go with this next question. Thank you for giving us the architecture, the framework on how to think about this. When you look at it on the business model side, I've seen kind of 2 different approaches right now. One being we're going to solve something we get paid for and the data is on the back end, and the other being the data is the value proposition that drives what the customer is paying for. As you think about driving down cost and you think about greater accessibility globally, how do you think about that in terms of creativity in the business model as well?
I actually think you answered the question, right? Which is that you actually, if you have a data-first mentality, it actually opens up how you might develop products against it, right? It's those key insights. I had breakfast this morning with some folks, and they actually made me really think about this. There's 3 legs to the stool on how you innovate in this industry. There's this great technological element, right? There are the developers, there are the engineers. There's the data side of things. But I think the companies that are going to change the business model are also going to be very clinician-oriented. So you can't do this without clinicians. So I think you have to kind of, if you're, and I spent a lot of my career in marketing, I always think about who's going to use this and who's going to pay for it. And you have to hook them first in your design of a product and business model. And if you can do that, they will pull this along. And the great thing we've had at Proprio is that we have 20 amazing surgeons in the medical advisory board. So I like to say it was built by surgeons, for surgeons, with surgeons. Right? It's not like we're going to drop this in front of them and go, what is this? I don't know how to use this. So my company, Evolve, is a company that sells a $120,000 weapons detection system. It's a subscription business. You pay by the month. It is 15 times more expensive than a metal detector, and price doesn't bother because it actually allows 10 times to 20 times more customers to pass through without emptying their pockets. So if you provide a condition for the users of these technologies that is so compelling, they will help pull you through on the business model. And there are ways to finance it, there's ways to do this. So the biggest challenge, I think, with a lot of large-scale medical devices, it's like, hey, it's $1 million. That's a very difficult opening conversation. But if you can show, and I always remind startups, visit the purchasing department early in your engagement with a customer and figure out how they spend money. Hopefully, I give you a little bit of a flavor.
Thank you very much.
Thank you.
Thank you, Alan. I think we're coming up on time, and I know there are many more questions, so you may get hit on the way out here.
Thank you very much. I appreciate everybody's time.